Hello everyone, welcome to today's session on the human eye and the colorful world. The other concept that is the scattering of light. So what is scattering of light, guys? So scattering of light is the process by which light is redirected into different directions when it strikes tiny particles. Like in the atmosphere or in the air, we'll have dust, air molecules, and water droplets. If it is rainy, we will have air, water droplets, and everything, and also dust in the atmosphere. So, scattering of the light is when it hits any obstacle, like for example, dust. So then it redirects, right? So if your dust is not a transparent material which can allow light, so it changes the direction and redirects from, and the light travels into a different direction. And if some other obstacle comes, like a water droplet, then it refracts further. So the the direction of the light gets changed when it hits any obstacles like the dust, air molecules, and water molecules. So this phenomenon is called scattering of light. Okay, so why this scattering occurs, right? So the atmosphere contains many dust particles, right? Dust, water droplets, gas molecules, and rain, and also air molecules, right? So when sunlight hits these particles, it bounces off in different directions, right? So for example, I have a wall. If I on the light, so it goes to the, if the light ray hits the wall, it reflects back, right? Because it cannot penetrate, it cannot travel through the wall, right? So same case here. When a sunlight hits the particles in the atmosphere, like the dust particles, what happens is it turns into a different direction. It bounces and turns into a different direction. That phenomenon is scattering. And here again, the white light, which has 7 colors. So shorter wavelength, like WIPGR, right? The violet through blue. This color light has shorter wavelength. So what happens is it scatters more. And similarly, red and orange, which is higher wavelength, that scatters less because it travels fast. So what is this? What affects that this scattering of light we can see in our day-to-day life? That is Tyndall effect. So what is Tyndall effect, right? So when we see a sunlight in a dusty room, let's say in the morning you have opened a room which has dust and more dust, right? So when you see the sun rays passing through, what you will feel is the sun rays, you feel that the it is like a kind of dust, and the light ray, you can feel the dust. When it is a dusty room, when the sunlight is falling, you can see that dust, more and more dust particles. That is because on each dust particle, the light takes different directions, so we can easily see the dust particles. But if you turn off that sunlight, if you close the window, you cannot see that because the dust has not gone, right? The dust is still in the room. But because of this scattering, we can feel the dust. We can see the dust easily. Okay, because light takes different directions when it hits the obstacles like the dust particles. So that's the scattering of light. And this effect is called the Tyndall effect. That's the sunlight in the dust room. That's one example. And also sunrays filtering through tree leaves in a forest. So when you are walking in a forest or a uh, dense area where we have trees, so the sunlight that you see, right, that is also, you'll see all the dusty particles, whatever the obstacles we see, every minute detail we can see very clearly. So that is the Tyndall effect. So it's basically, the Tyndall effect is the visible scattering of light by colloidal particles. Okay. All right. Then what are our day-to-day examples of scattering of the light, right? So we always see the sky is blue, right? So that is the example of, that is the effect of the scattering of light. Let's see how. So blue light, which has a shorter wavelength, right? WIPGR, right? So in WIPGR, VIB GR, right? So blue light has shorter wavelength compared to orange and red. Is scattered much more than red light, right? So this has shorter wavelength. So what happens is it scatters more than the red light by air molecules. So when we look at the sky, we see mostly scattering blue light. So basically why we see a sky as blue is the most visible lights are blue and red. So this red light has higher wavelength, so it doesn't scatter much. So blue light has shorter wavelength and it scatters more. So we will mostly see the blue light. That's why we always see the sky is blue. Why is the sun red at sunrise and sunset? So whenever we see sunrise and sunset, we see the sun is red. So during sunrise and sunset, sunlight travels longer distance through the atmosphere. So when it travels longer distance, blue light gets scattered out. So we cannot see like all these colors with GRs, right? V, B, G, up to Y, we will not be able to see. So orange and red, these travels very fast. So less scattered. So that's why we feel it is orangish and red during the sunset because it is very far. It has to travel long distance during the sunrise or the sunset. That's the highest distance that light ray needs to travel. When it is at the noon, it is just exactly opposite above our head. So that is the shortest distance that light ray needs to travel. But during the sunrise and sunset, that is the longest distance that light ray needs to travel. So during that time, this blue, all these colors will disappear, scatters more and we cannot see. And red, as it scatters less, we can see that red color or orange color when the sun during the sunrise and sunset. Only that color will retain uh, until the sun ray travel and hit our eye from that long distance. Then, why are the danger signals red? Yeah, wherever we see the signals are red in color, right? Red and also green. So why we use that? So red light scatters the least, so it can be seen from long distance. Like how we see sunrise and sunset in a red color, because red scatters very less. So you can see that from very long distance. If I keep a blue light, right? So blue light scatters easily and you cannot see from very long distance. So why we use the signals in red is the red light scatters the least, so it can travel long distance through a normal atmosphere, and also if there is like a rain or a fog or a smoke, then it can still be visible. The red light is still be visible because it scatters less. So hence we use the signals in red color. Understand, guys? So that's the scattering of light. So what we have learned today, so that's the atmospheric refraction. And then what is the real-time use cases? And then what is scattering of the light? Scattering of the light is nothing but just uh, the light is redirected, right? Redirected when it hits the obstacles like dust particles or water droplets or that thing. And what is Tyndall effect? And what are our day-to-day scenarios where we see the scattering of the light? Why sky is blue? Because the blue light scatters much because of its shorter wavelength. So it will see blue everywhere. Red we will not see because it scatters very less. Then why is the sun red? Because it has to travel long distances during sunrise and sunset. So as red light uh, scatters less, we will still able to see that red color. Then why are danger lights red? Because we can see in any type of weathers like rainy weather or smoke, fog. During those times also a person can weave that red color from long distances because it scatters less. Okay, so that's the uh, scenarios where the scattering of the light helps, guys. So yeah, thank you. That's all for today's session, and hope you guys understood the topic. And in case you have any questions or concerns, you can contact me using my Urban Pro profile. Thank you, guys.